All right, let's get into it. Today, we're going to pull back the curtain on the pretty wild world of sports prediction. We're going to see exactly how artificial intelligence takes a game of pure passion, a game of chance, and tries to turn it into a forecast built on cold, hard data.
You know, soccer is the beautiful game for a reason, right? It's famously unpredictable. It's all about those last-minute goals, those shocking upsets, and just pure human drama. So the big question is, can an algorithm, can a piece of code really get a handle on a sport that so often just completely defies logic?
To find out, we're not just going to talk theory. Nope. We are diving deep, and I mean deep, into the AI-powered analysis for one specific match from the Spanish League, Elche CF taking on Athletic Club Bilbao.
Okay, let's jump right in. So before any of the really complex AI stuff can even begin, the system has to start with the basics. It has to look at the same exact information a human analyst would, just the simple facts on the ground.
And right away, you see the first big hurdle. We're not talking about teams at their absolute best. Elche is missing key players like Hector Fort and David Affengruber. Meanwhile, Athletic Club is without Ohan Sansit, and Yeray Alvarez is suspended. For the AI, these aren't just names on a list. These are massive variables that have to be factored in.
So this slide gives us our first real piece of data to compare these two. Using the ELO rating system, which actually came from the world of chess, you can see a pretty big gap here. Athletic Club is rated significantly higher than Elche. So, on paper, you'd think, okay, Athletic Club is the stronger team. But as we all know, games are not won on paper.
So how does this all build up? I mean, how does an AI take a simple strength rating and turn it into something actually useful, like a goal forecast? Well, it all starts with some pretty classic statistical tools. First, let's just quickly touch on that ELO rating again. It's not some static number they slap on a team at the start of the season. No, it's a dynamic, living thing. It's constantly adjusting up or down after every single match based on who they played and what the result was. It's like a live pulse check on a team's current form.
Now, with that ELO rating as a key ingredient, the system then uses a statistical model called a Poisson Regression. Sounds complicated, but its job is actually pretty powerful and simple. Predict the number of goals a team is likely to score, taking into account things like team strength and, of course, that all-important home field advantage.
And here's what it spits out. After crunching all the numbers, the Poisson model calculates that Elche, the home team, is expected to score 1.08 goals. So, basically, just over one goal.
But this is where it gets really interesting. Even though Athletic Club has that much higher ELO rating, their expected goal count is actually lower at just 0.87. And that, right there, is the home advantage factor quantified. The model is saying that being on the road is going to suppress the stronger team's ability to score.
But look, expected goals from one model is just the beginning. To really find an edge, you have to dig way deeper to find the patterns that nobody else sees. And this is where the real heavy hitters, the machine learning models, enter the game.
Traditional stats are great, but they can miss the really complex stuff, They miss those weird, non-linear relationships in the data. That's what these next models are designed to do, to find those hidden patterns.
First up, we've got the random forest model. The best way to think about this is like a huge committee of hundreds of individual experts, each one looking at the data from a slightly different angle. And their combined vote is pretty clear, a 65% chance of a home win for Elche.
Next in line is XGBoost. This thing is a beast. It's famous in data science competitions. It learns by constantly correcting its own mistakes one step at a time. And it's even more confident, pushing that home win probability all the way up to 72%.
And finally, the neural network. This model is kind of inspired by the human brain, and it's built to find the most abstract, complex patterns hidden deep in the data. It comes back with the highest conviction yet, putting Elche's chances of winning at a commanding 79%. So we've got several powerful AI models, right? And they all seem to agree that the home team is going to win, but they're all giving us slightly different probabilities. So what now? How do you get from all these different opinions to one single definitive forecast?
Well, the solution is another layer of AI, a stacked model. You can think of this one as the team manager. Its only job is to learn the strengths and weaknesses of its expert coaches, those other models, and then decide how much to weigh each of their opinions to make the smartest final call possible.
And here it is, the final verdict from our team manager. After blending all the different inputs, the stacked model lands on a 68.45% probability of a home win for Elche, with about a 22% chance of a draw.
It's a confident prediction, but as you can see, it's a bit more nuanced.
But a percentage is still just a number, right? It's kind of abstract. I mean, what does a 68% chance of winning even look like in a real soccer match? To make this tangible, we need to translate that probability into something we can actually visualize, a potential final score.
And for that, we turn to a Monte Carlo simulation. This is a really fascinating process where the AI basically plays the match on a computer 10,000 times, using the goal probabilities it already figured out. It's like a massive digital dress rehearsal on a huge scale.
So after running those 10,000 simulations, the patterns start to emerge, and the single most common result? A 1-0 victory for the home team, Elche. That specific scoreline happened in over 15% of all the simulated matches. That is what a 68% chance of winning looks like in practice.
So, we have our prediction. A 1-0 win for Elche is the most likely outcome. But now we get to what is easily the most important part of this entire analysis, understanding the limits of that prediction.
And I really want to focus on this crucial disclaimer. A 68% chance of winning also means there is a 32% chance of not winning. The model identifies what's most probable, not what is certain. This is a guide, not a crystal ball.
And all this kind of brings us to our final thought. As AI gets better and better at dissecting every little element of the game, it poses a pretty fascinating question for all of us who love the sport. When a game can be broken down into code and probability, where does the magic of being a fan actually lie? That's something no algorithm can ever answer.